Hi, everyone. Okay. Hi, everyone. I'm Lydia Liu. I'm an assistant professor in computer science at Princeton University, and I'm excited to be the session chair for our first session on resource allocation, moderation, and participation. So just as a recap, the talks are around 12 minutes long. So when there's at the 11th minute, not the 11th hour, I'll give you a hand signal that you have 1 minute left. And so our first session for today, our first speakers for today will be the authors of the paper AI Self-Preferencing in Algorithmic Hiring, Empirical Evidence and Insights. And the authors are Jiannan Xu, Gujie Li, and Jane Yang. Okay, let's welcome them. Do we have the speakers here? Okay, great.
Okay, hi everyone. For today's talk, I'm going to present one of my recent paper, AI self-preferencing algorithmic hiring, empirical evidence and insights, which is a joint work with two of my fantastic authors, Gujie. He's from National University of Singapore, and Jiang. Currently, she's at the Health State University. So with that, let's get started. Okay, so for this talk, I would like you to think about you or someone you know apply for a job. The chances are nowadays, the first decision wasn't made by a human at all. It was an algorithm screening all of the resumes before a human ever look at them. And that's what we call algorithm hiring. So for some people, it's actually quite exciting because they are so optimistic about AI. It means faster and smart decisions, right? And AI can actually reshape the entire hiring landscape. But for other people, actually, this comes as a warning sign because these tools may not just simply speed things up, they can also lock people out, amplifying biases, and making their job search even harder. So what is happening under the hood? Nowadays, as we all know, we are using large language models in our daily life. And these kind of large language models, they are actually showing up on both sides of the hiring table. So on one side, we have the candidates who are drafting or revising their resumes using these AI models. But on the other side, we also have the recruiters who are using the similar tools to screen candidates. And guess what will happen? So we have a unique AI interaction. Well, the model ends up judging its own output. So in hiring, this could mean a candidate who happen to use the model as the recruiter's model will get some comparative advantage, while other equally qualified candidates may get locked out in this process. And that even raises a bigger concern. When large language models showing up on both sides of the hiring table, can we still call this process fair or not? So with that in mind, here's where things get even more interesting. So recently, we have computer scientists, they kind of discover an emerging phenomenon about large language models. So these models, they can actually distinguish whether a text is written by themselves versus is written by a human or alternative models. And that's what we call AI self-recognition. And as you may notice, nowadays, we are using large language models across different scenarios, and especially these two-sided decision-making scenarios. So we have two-sided parties get involved. And it's not just about algorithm hiring. It can be supply chain procurement. Well, we have the company bidders, they are also crafting their bidding statement using the models. And it's presumably the government, they may have the potential to leverage the AI tools to screen the bids. And it can also be like AI grading or even content moderation. As long as there are this kind of two-sided decision-making scenarios, there might be exist a risk of bias. So basically, once the model becomes self-aware, may start to prefer its generated outputs. And that's what we call AI self-preferencing. So basically, it means that when a model starts to recognize its own fingerprints, it may start to prefer the content generated by itself versus the content written by a human or generated by alternative models. Okay, so with that in mind, we want to kind of rigorously examine the AI self-preferencing behavior, like does this bias exist or not in the context of algorithm hiring? And we answer the following research questions. So basically, first we want to see does it exist or not. And in the paper, we kind of like formally define there are two layers of bias. So it can be the bias between the model and the human. That's what we call LM versus human self-preference bias. Another layer is like the bias can also exist between the model versus alternative model, and that's what we call LM versus LM self-preference bias. So with those definitions, then we try to do a very rigorous evaluation across what the major language models used in our daily life. So both open sourced and closed sourced to assess what's the magnitude of this bias across these natural models. And after that, reasonably, once we identify this bias, then like a natural question we want to tackle is that what are the mitigation strategies that we can leverage, and how effective are these strategies? Okay, so to answer these research questions, then we leverage a large-scale resume dataset, which is collected prior to the era of large language models, making sure all of the resumes they are indeed written by a human. So the dataset was collected in 2018. So at that time, natural language models is still not at a big thing compared to what we have nowadays. And the good thing about the dataset is that it also spans across different occupations, which gave us a lot of heterogeneity to explore. And it's also widely used by AI researchers as a benchmark dataset to do algorithmic audits to assess the demographic-based disparity biases. Okay, so with this good dataset, then naturally we want to have a mathematical framework that help us to quantify this bias. So we look at the literature, and then we use the equal opportunity concept from the furnished machine learning literature, and we formally define the AI self-preference bias. So there we have the mathematical formula. It's the differences between two conditional probabilistic terms. But the high-level intuition is quite simple. So suppose we have an AI evaluator model, then the probability for that model to select the candidates out of two equally qualified candidates, like one is using AI to revise the resume, but the other one is using the human written resume, then the chances for selecting one candidate from these two should be the same. So in the ideal world, you should expect these differences is close to 0. Okay. So with that framework, then naturally we want to design a rigorous experiment to help us to quantify the bias. So with that in mind, we design a resume correspondence experiment. So as a first step, we want to have a counterfactual resume compared to the original human written resume. So as the first step, we want to do counterfactual resume generation. So we have the original resume. Then we redacted the professional summary section from that resume such that we can get a redacted resume. Then we send this resume to a suite of large language models and to ask the AI evaluator to reconstruct the professional summary based on the rest of the content, such that we can obtain a counterfactual resume. So as you can see, through this process, the qualification, like the skills or the experience of the candidate is the same because at the end of the day, it's the same candidate. The only difference is just the professional summary section, like whether the summary is written by a human as it is in the original resume, or it is generated by the AI using the rest of the contents. So with these two resume in hand, then we have then we do like a pairwise resume evaluation. We will send this pair of resume to a suite of large models and to ask the model to make the choice, like which candidate do you feel is stronger, and select the better candidates. And through this process, we also like one thing that we need to control basically is underlying quality of these two resumes. And we in the paper we take a combinatorial approach. So the first one is just to ask human annotators opinions as the ground truth. And another approach is to leverage linguistic features as the underlying proxies of the quality of these two resumes. But due to time limits, so in this talk, we are just focused on the later approach, where we leverage linguistic features as the proxies of the underlying quality. So after we set up everything together, then we can just estimate the self-preference bias that I introduced earlier. And the empirical strategy we take is quite simple. We just estimate a conditional logistic regression while we control the underlying quality of the resumes. So the parameter that we want to identify basically just a beta 1, and it captures the tendency of the model to prefer whether the content is generated by itself versus the content written by a human. The dependent variable is just whether the model prefers a specific resume or not, while the independent variable is the source of resume, whether it's human written or AI generated. And after we identify beta 1, we can do a signal transformation, and after that, we can estimate the conditional probability differences that we introduced earlier. Because time limit, let's just take a look at the interesting results. So for the first layer, we have the LM versus human self-preference bias. So as you can see, there's a very consistent pattern across the major large language models used in our daily life, whether open source or closed sourced. After controlling the underlying content quality, we see that most of the models, as long as the parameter is above 10 billion, they exhibit self-preference bias. So with magnitude ranging from 68% to 88%. And it's quite a striking finding. So with that in mind, then we want to see what's the potential implication of this AI self-preference bias. So in the paper, we kind of like simulate a very realistic hiring pipeline where we have a bunch of candidates. They are in different occupations and they will revise their resumes. But at the same time, we have the company who leverage the AI models to do the evaluation. And surprisingly, we find that for the candidate who happen to use the same model as a company's model, they will have comparative advantage of being shortlisted compared to other candidates. And the probability boost is about 22% to 60%. And another interesting finding through this exercise is that across all of the occupations that we tested, actually the business-related majors such as sales, accounting, they are most vulnerable in front of the AI self-preference bias. Okay, so after we identify the bias, then a natural question is how we can mitigate this bias. So we leverage the potential mechanism like discovered in the literature. Basically, once the AI can recognize its own fingerprints, then the AI starts to prefer itself. So we specifically target this potential mechanism and propose the following two mitigation strategies. So the first one, basically, we can do a system prompting to ask the model to ignore the differences between the AI written resume versus human written resume. And the other approach is more like we have majority voting where we intentionally create an ensemble of models and we do not rely on a single model's judgment, but instead we rely on the collective decisions of this suite of models, such that we can incorporate some of the models. They are not so well self-recognized, but in order to kind of dilute the self-preference behavior of this ensemble. So after I presented so many like depressing results, we have a very encouraging mitigation strategies here. This AI self-preference bias can actually be effectively mitigated using these two simple and effective mitigation strategies. Okay, and because time limit, I kind of like just quickly wrap up of the talk. So in this paper, we kind of first identify this AI self-preference bias in algorithmic hiring context. And we find that the LM versus human self-preference bias is quite substantial and pervasive across most of the major natural models we use in our daily life. And there are potential implications for the candidates being shortlisted if they happen to use the model as the same model as the recruiter's model. And we can design effective mitigation strategies based on the potential mechanism behind. And most importantly, I think the one thing that you want to take from this talk is that a lot of time when I talk about algorithmic audits, we put a lot of attention on demographic disparity features, like such as race, gender, or age. But due to this kind of unique AI interaction, it may also disadvantage some of the candidates in different scenarios. And with that, I'll conclude my talk. And our paper is posted on SSRN. If you are interested, feel free to check it out. Thank you.
Thank you, Jiannan. Do we have any questions? Yes. Over there.
Oh, okay. Shall I suggest that here?
Hi, thank you very much. Quick question about the metric. Are you comparing, like, is the self preferences, the LLM has written this text and I prefer only my own text, and I compare against text that is written by any human or any other model, or I'm comparing really human text against any text that is written by any LLM model?
Oh yeah, that's a very good question. Because of time limit, we only cover the first layer of a bias. So that's a bias between the LLM versus human. So it's like whether the content is written by is generated by an LLM versus is written by a human. But in paper, we also like kind of discussed and discover like the second layer of bias is the LLM versus alternative versus LLM self-preference bias. So it's more about like whether the content is generated by DeepSeek versus the content is generated by GPT-4o. And we can like one thing that we find is that actually if you want to revise your resume, please use DeepSeek, because a lot of models they show the worst self-preference towards DeepSeek. Basically, DeepSeek also like strongly prefers the output generated by itself. So if let's say if you are using DeepSeek, but the other candidate is using GPT-4o, and the recruiter is using DeepSeek, then you have like a better chance of being shortlisted.
Okay, I think let's transition to the next speaker and take the rest of questions offline. Thank you so much.